The last method of this section is using the quadratic formula to solve quadratic equations. This is the most versatile method because it can solve any quadratic equation. Let's go ahead and see what this formula is. Suppose we're given the following quadratic equation: ax squared plus bx plus c is equal to 0. Then the solution to this equation is always given by the following formula. X is equal to a negative b plus or minus the square root of b squared minus 4ac divided by 2a. The underside of the square root is called the discriminant. And the discriminant allows us to determine what types of solution the equation has, whether it has two real numbers as a solution, one real number as a solution, or if it only has complex numbers as a solution. Let's go ahead and list these possibilities on the next page. If we have that the discriminant is equal to 0, then we have one real solution. If the discriminant is greater than 0, then we have two real solutions. And if the discriminant is less than 0, we have two imaginary solutions. Let's go ahead and find the discriminant and then describe the solutions and solve the following equations. Our first quadratic formula will be given by 8x squared plus 14x plus 3 is equal to 0. We'll go ahead and look at the discriminant, which is again given by b squared minus 4ac. This is equal to a 14 squared minus 4 times 8 times 3. Plugging this into a calculator, we'll get that this is 196 minus 96, which is equal to 100. This means that our discriminant is greater than 0. And so our quadratic equation has two real solutions. Let's go ahead and solve this now. Rewriting our quadratic, we have 8x squared plus 14x plus 3 is equal to 0. The quadratic equation tells us that this is going to be solved by x is equal to a negative b plus or minus the square root of our discriminant divided by 2a. Plugging in our a, b, and c, we'll get negative 14 plus or minus the square root. Since we found the discriminant in the last term, this is going to be 100, all divided by 2 times 8. Simplifying this, we get that this is equal to a negative 14 plus or minus 10 divided by 16. Then this is either equal to a negative 4 divided by 16, or it's equal to a negative 24 divided by 16. In part B, we're given the quadratic equation 3x squared minus 10x plus 15 is equal to 0. Finding the discriminant first, again, this is going to be a b squared minus 4ac, which is going to be a negative 10 raised to the second minus 4 times 3 times 15. Plugging this into a calculator, we see that this is going to be 100 minus 180, which is equal to a negative 80. And this is clearly less than 0. So the discriminant is telling us that this is going to have two complex solutions. Let's go ahead and find what these complex solutions are using the quadratic formula. Plugging in all our information, we'll have 10 is plus or minus the square root of our negative 80 divided by 2 times 3. Simplifying this is going to be 10 plus or minus I times the square root of 80 divided by 6, which is about as simplified as we can get, and so this will be our final answer. Let's go ahead and solve one more example. Example 5. Find the solution to the following quadratic equation: 9x squared plus 3x minus 2 is equal to 0. Again, we're just going to use the quadratic formula, which is going to be equal to a negative 3 plus or minus the square root of 3 squared minus 4 times 9 times a negative 2, all divided by 2 times 9. Plugging in to a calculator the under the square root, we'll get that this is going to be 9 plus 72, all divided by 18. Since we have our 9 plus 72, this is the same thing as 81, which means that this is going to be equivalent to the negative 3 plus or minus 9 divided by 18. The numerator will have two solutions. Either we'll have a negative 12 divided by 18, or we'll have a positive 6 divided by 18. Just as a related note to the quadratic formula is the Pythagorean theorem. So this is just one last side note to this section. And this is just a reminder that given a right triangle, we always know that the sum of the square of the two lesser sides is going to be equal to the square of the longer side. In this picture, this is given by a squared plus b squared is equal to c squared. Let's look at one more example, and let's find the missing side of the triangle given by the following: 4, 10, and this side is x. Here we'll have x squared plus 4 squared is equal to 10 squared. Subtracting a 4 squared from both sides, we'll get x squared is equal to 100 minus 16. Then x squared is going to be equal to 84. X is then equal to plus or minus the square root of 84. Since our triangle doesn't have any negative sides, what we're left with is x is going to be equal to the square root of 84.